Hi, I am Tiago from Electrical Engineering Tutorial Education Program, and today I want to show you a simple electronic project called by Clap Your Hands Light Switch, where I will turn on a lamp by 2 clap of hands and turn off this lamp by 1 clap of hands. So let's get started. Here we have a scheme for this project, and here we have the power supply for the lamp. I am using a 127 volts in alternating current lamp. I will need a relay to switch this lamp, and we will send signals to this relay from a microcontroller. In my case, I am using the NSP430G, but you could use another microcontroller or development launchpad like Arduino as well. So to this microcontroller we will connect a sound sensor that will of course include a microphone, and here we will detect how many and when we clap our hands. And in the microcontroller we will implement a routine to identify the number of claps and then send a signal to this relay, and this relay will switch and turn on the lamp or turn it off. That depends of the number of claps. First, I will make this part of the project, so I will use a few meters of red wire and blue wire, a lamp socket, and a relay. Here I will connect a plug so I can easily connect and disconnect from the power supply. For this project, I will use this relay, and as you can see here in the datasheet, this model has a nominal voltage of 5 volts in continuous current. It also has a rated current of 125 volts in alternate current, so this model is appropriate for our project. Down here we have a schematic for this relay. And in these 2 terminals we will connect the microcontroller. Here we need to provide 5 volts in order to switch the relay. In this terminal we will connect the red wire, and here we will connect the lamp. This terminal we won't use, so you can let it in open end. Now we need to implement a routine to send signals to the relay, but first let's have a look at our sound sensor. For this project I'm using this model, and it has 2 LEDs. LED 1 will show that the sensor is supplied with voltage, and LED 2 will show that the sensor is detecting a sound. As you can see here, this model has 4 pins, and we need to provide 5 volts in pins 2 and 3, And for this project, we will use the digital signal pin, and this pin should be high if the sensor detected a sound, otherwise it should be low. With this model, you can increase or decrease the sensitivity. To increase the sensitivity, we go to this direction, and to decrease the sensitivity, you go this direction. If you increase the sensitivity, your sensor will detect more and more lower sounds, and if you reduce the sensitivity, your sensor will not consider a range of lower sounds. What I will do is decrease the sensitivity until the LED 2 turns off. So I know that the sensor is not considering the environment sounds, and then the lamp will not turn on or turn off with these sounds. With that in mind, we can implement a routine, charge it in your microcontroller, and then see if our project is working. So let's do it. First, what I will do is define some variables that will be useful to your program. I will use the pin 13 of the MSP430G launchpad to connect the digital sound pin of the sound sensor. I will use the pin 11 to connect the relay, and then I need one variable to define the maximum time of one clap. This variable is given in milliseconds, and it's needed to not detect one clap more than one time. And then I need another variable to define the maximum time between claps, and this variable is also given in milliseconds, and it's needed to detect how many times we clap our hands. I also need one variable to count the claps, one variable to count the time of one clap, and one variable to count the time between claps. This function doIt will send signals to the relay, but we will implement it later. In the setup function, we need to define the sound pin as input and the relay pin as output. The first thing that we will do in the loop function is to read the value in the sound pin, and then we will use a if condition to see if this value is high. If this value is high, then we need to check if we are not counting the same clap more than one time. To do that, we will use another if condition to see if the time of one clap is equal to 0. If this if is true, then we can charge the wait time of one clap and the wait time between claps with the value in the function millis, and then we can add 1 to your count clap. But if this if is not true, then we need to see if the value in the millis function minus the wait time of one clap is bigger than the maximum time of one clap. If this if is true, then we need to reset the value in the wait time of one clap variable. As I said, this part of the code is important to not count one clap more than one time. After that, we need to check if we have some values in the count clap variable and if we are not waiting for another clap. To do that, we can use a if condition and see if the count clap variable is not equal to 0 and if the value in the millis function minus the wait time between claps is bigger than the maximum time between claps. If this if is true, then we can call the function doIt, we can reset the count clap variable, and we can make the wait time between claps equal to the value in the millis function. Finally, we need to implement the function doIt. I will use a switch function that will receive the count clap as argument, so this switch will have two cases, and case the value in the count clap is 1, then I will put the relay in low state, and this will correspond to turn off the lamp. Here I need to use a break to exit the case statement, and case the value in the count clap is equal to 2, then I will put the relay in hide state, and this will correspond to turn on the lamp. And here I also need to use a break to exit the case statement. So this is our sketch, and we just need to save it and charge it into our microcontroller. Now I'm going to connect this part of the circuit on the proto board. So here we have the MSP430G launchpad, and here we have our sound sensor. This pin is our relay pin that we previously specified on your sketch, and here we have the digital signal pin of the sound sensor. In these two pins we need to connect the power supply that will be provided from the MSP430G launchpad. Well, here we have a little issue, because if you have a look at the MSP430G datasheet, you can see that the output pin's voltage is close to 3 volts, and we are using a relay that will switch with 5 volts, so we need to find a way to fix it. What I will do is use a transistor as a switch to connect the 5 volts provided from the launchpad to the relay. For this project, I will use this model of NPN transistor. And here we can see that the maximum collector emitter voltage is 30 volts, but we'll only use 5 volts. Down here, we can see that the 3 volts provided from the NSP will make the transistor work as a switch. So let's connect this part of the circuit on the proto board. Now it's time to retest our project. I already adjust the sound sensor to not consider the environment noise, and we expected to turn on the lamp with 2 claps and turn off with 1 clap. So let's see if it's working. This is it for today. I hope you guys enjoy it, and see you. Bye!